Today we're doing section 4.4, reference angles, day 2. So we're going to again discuss the use of reference angles and how they're beneficial to us. So 135 degrees falls in quadrant 2. And we kind of discussed the shortcut that it's always going to match up with either a pi over 6, pi over 4, or a pi over 3. So 135 degrees is going with our reference angle of a 45 degrees. And then from here, we just got to figure out the signs. So remember, we know that all students take calc rule. So because we're in quadrant 2, sign will be positive. So I know our answer is going to be positive. And I know the coordinate for 45 degrees is root 2 over 2 and a root 2 over 2. So sine is y over r is obviously 1, so the answer will be root 2 over 2. Now, do you have to write all this out? No, a lot of this stuff is, things you should be saying and walking yourself through in your head. You don't have to necessarily write it all out. Letter B, our reference angle will be a pi over 3, and the coordinate for a pi over 3 is 1/2 and a root 3 over 2. 4 pi over 3 is going to fall in quadrant 3. And we know in quadrant 3, tangent is positive, which means cosine and sine are both going to be negative. So cosine is x over r. So 1/2, and because we're in quadrant 3, cosine is negative. Now that's one way to think about it. Some students prefer, because we're in quadrant 3, we know the coordinate looks like a negative. Some prefer to put the negatives there and then determine your answer. So go ahead and try the practice problem of the cosine of 7 pi over 6 and input your answer in the video. So again, we're going to work on same deal, just now the angles are a little bit bigger. So we're going to work on finding a coterminal angle first. So 14 pi over 3, we need to subtract out the 2 pi. Common denominators will be 6 pi over 3. So first round of subtracting puts me at 8 pi over 3. This is still too big, so I need to take out another round of 2 pi. And that puts me down to 2 pi over 3. And now from here I can determine that my reference angle will be 1 pi over 3. And the coordinate for pi over 3 again is 1/2 and a root 3 over 2. So we will be in quadrant 2 with that original 2 pi over 3. So we know that tangent is negative in quadrant 2 because it's the whole ASTC. So tangent will be negative, so that's one way. Or because it's quadrant 2, we know x is negative, y is positive, regardless of how you spin it. I take tangent as y over x. So I have root 3 over 2. And I'm dividing by negative 1/2. We know we keep, change, flip. So I'm keeping, I'm changing, I'm flipping. The 2's cancel, and the final answer is negative root 3. Okay, so let's try one more. So this one is going to bring back the even and odd identities. So secant is even, which means the negative gets dropped. So this is the same thing as evaluating secant of a positive 17 pi over 4. Still large, so we're going to have to find coterminal. Common denominators for 2 pi with a denominator of 4 will be 8 pi over 4. So 17 minus the 8 will put us at 9 pi over 4, which is still too large. So we subtract another round of coterminals, and that puts us at pi over 4. So this one actually doesn't have a reference angle because the angle is already less than 90 degrees or acute. So my angle is pi over 4, which means we are going to be in quadrant 1. The coordinate is root 2 over 2 and root 2 over 2. And because this is secant, this is r over x. So I have 1 over my x value And we'll flip it. Then we need to rationalize, so I times top and bottom by that root 2. So I get 2 root 2 over 2, and the 2's cancel, so the final answer is root 2. So that's all for today. We're going to do some more practice on this tomorrow.